Welcome to our webinar. My name is Martijn Siemes. I am a communications officer here at the Open Charge Alliance, and I will be your host for the next 45 to 60 minutes. In this session, we will be discussing the new UK EV regulations in regards to OCPP, smart charging. We will start off with a presentation by my colleague Milan Jansen on the white paper the OCA has now published on this subject. After the presentation, I'll introduce to you Ashley Grealish of EV.Energy and Mathieu Falcy of Schneider Electric. They will share their views on the subject. During and after these presentations, you can ask questions in the questions box. And this webinar will be recorded and you can watch it later on our OCA YouTube channel. For now, Milan, are you ready?
Yes, I'm ready, Martijn.
Okay, the floor is yours.
Thank you. So today I'm going to talk about the UK regulations for electric vehicles and smart charge points that's what are released, and how you can use OCPP to accommodate for those requirements. My name is Milan Jansen. I'm a technical editor for the Open Charge Alliance, and I will be giving this webinar instead of my colleague, Frank Boeve, who wrote the white paper. So the EV regulations they published are because in 2035, the UK wants that all vehicles and vans will be fully electric. Sorry, screen is in my way. To avoid excessive strain on the electricity grid, you need some regulations for all private charge points that are being sold in Great Britain. Going to the next slides. Yeah. So these are the documents that are about these regulations, and on the right side you see the white paper that the OCA released regarding this topic, because at the Open Charge Alliance we always want to be ahead of these kind of regulations and provide the market information on how to use OCPP to implement those. So in a nutshell, the UK regulations consist of a few topics. So it applies for both domestic and workplace charge points. And these charge points are required as of June 30th to prevent charging during peak hours or provide demand response services. However, the user, the EV rider, always can overrule these, so it can always start charging if he really wants to. And there are some additional features necessary, like that the starting of the charging is not immediate. It needs to be randomized. There are several reasons. They want to do it like when there are power outages, but also for when you are introducing peak hours and preventing charging during those peak hours, that you don't want all vehicles to start charging at the same time. So that's where the randomized delay comes into place. What's also necessary is that you don't need to be bound to your electricity supplier. So the charge points still would need to be able to do smart charging also when you switch electricity supplier. And the charging stations also need to report the power flow, so the amount of power that's being transferred every second according to these regulations. And later this year, the security requirements will go into effect. So the market has a little bit more time to implement these. when a charge point stores passwords, they need to be protected. The firmware updates need to be secured. The communication channel between the charge points and between the management system needs to be secured. When there are security events like the tamper protection, so when someone is messing with a charger, these events need to be notified by the charge points. And all these security related information needs to be stored in the charge point. So now we know what all the requirements are. We can focus on how we can accommodate these with OCPP. So first, the electricity supplier interoperability. OCPP is a standard, so as long as the systems implement OCPP, all systems can communicate with each other, and you can keep doing smart charging in exactly the same way. Also, the charging profiles will keep in effect, which I will talk about a bit more later during this presentation. The measuring of power and energy is a very core feature of OCPP. It was already a feature in the first versions of OCPP where there are meter values being transmitted. In OCPP, you can transmit all kinds of metering related data, but here we are talking about the energy consumption, and yeah, that can be reported using those messages. We need smart charging functionality. OCPP already supports smart charging, and it uses a charging profile mechanism for this. And I will give you some examples later also for the next point where we talk about how you do the off-peak charging and prevent charging during the peak hours. We use so-called TX default profiles for this. As for the randomized delay, it's best to implement this in the charger firmware itself. But if that's not possible, then you can also use OCPP with the same TX default profile mechanism to support that as well. And as for the security, OCPP 2.0.1 supports security, and 1.6 as well, because we wrote a security white paper that maps all those security related mechanisms to OCPP 1.6 as well. So I'm showing an example of a charging profile that's being transmitted over the wire using OCPP here. It's a bit much detail, but I will go over the most important parts. Let me see if I can create a pointer. Laser pointer. There it is. So important part is that it's a TX default profile, and it's a recurring profile, which means it recurs after a specified time. So in this case, it's a daily profile, and we use this to simulate the weekdays, so the standard days, where we want to prevent charging during the peak hours. So the duration of this profile is 24 hours. And we have several charging schedule periods, which starts at 12 o'clock. And after that, the first limit will be imposed on 8 o'clock, where the limit is 0. So this will prevent charging from 8 o'clock until 11 o'clock, where it's possible to charge again, until 4 o'clock, where the charging is limited again. Of course, this can be overruled by the user, but this is how, for the whole week, you impose those limits. However, they don't apply for the weekends. So for the weekend, you create a second charging profile, which is also recurring but weekly, with a higher stack level, so it overrules the first one, and it's valid for 84 hours. So for the whole weekend, you have a period without a limit, so this is without a limitation for the charger, and so you won't have those limits during the weekend days. So as for the randomized delay, this way. Whenever the charging starts, you need a randomized delay up to 600 seconds. That is what is required. There are two approaches that can be used in this case. So you can either let it be controlled by the charge point itself or by the management system. I'll first talk about when it's being controlled by the charge point. In this case, it's a built-in feature, and what the charge point manufacturer can do is implement a configuration key or configuration variable, randomized delay, where the management system can configure this delay at the charger. And as for 2.0.1, we have a device model mechanism where we have a smart charging controller, which contains all smart charging related configuration settings. And part of this would be the best place for the randomized delay. The downside of this is that the charge points that are currently there do not support this feature yet. So the CSMS needs to check whether a charge point supports this, and if it does not support this, then it needs to control it itself. And when the management system needs to control it, it can use the same mechanism I talked about before with the charging profile mechanism. And what you can do is, when I go back to this one, you can adjust these periods with a randomized delay so that the limits go into effect at a bit different time. So instead of it going into effect at 8 o'clock, for the one charger, it will be 8:01, and for the other charger, it will be 8:04. And that way, not all chargers will start charging at exactly the same time. However, this does only work when someone starts charging during the peak hour, and then it waits for the off-peak hours. However, when someone starts charging during the off-peak hours, it starts charging immediately. So to accommodate that, you can provide an additional profile with a higher stack level, and you can make this profile relative to the start of the energy transfer with a randomized length up to 600 seconds with a 0 limit. So for the first few minutes of the transaction of the session, the limit will be 0. After that, the profile duration expires and it falls back to the other profiles we just talked about. So this way you can also impose the randomized delay. Regarding security, so secure communication between the charge points and the management system is required. OCPP describes 3 different security levels profiles. The first one is only HTTP basic authentication. The second one is also with TLS and server-side certificates. And the third one is TLS with both client-side and server-side certificates. OCPP already highly recommends to at least support security profile 2, so with the TLS. And for certification where security is included, we require at least the implementation of security profile 2. Secure firmware updates are also required, which is a use case in OCPP as well. What the management system does is when a firmware update needs to be done, it can send an update firmware request. In this message, it also includes a signing certificate and a signature. And what the charge point needs to do with these is one, well, what it can do with this is one, be sure that the firmware it's installing is verified and from a source that is trusted. And secondly, that it's not changed. So there has been no changes to that firmware file at the, since the moment the signature was generated. So you can be sure that the firmware is trusted in this way. So yeah, it needs the charge point needs to notify when there's some kind of breach or tampering with the protection, the hull of the charger itself. OCPP has standardized several security events, also critical security events that need to be reported immediately to the management system when they occur. I've put a few examples here because they're relevant for these regulations, like the tamper detection activated, security log was cleared, or the firmware update. So the charge points will report these critical events immediately when they occur. And OCPP also has a requirement that it is required that these kind of events are always stored in a security log, and this security log can be accessed by the management system. So the management system can request this information at any time. So to summarize, the UK regulations can be implemented with both OCPP 1.6 and OCPP 2.0.1 without any customizations. The randomized delay might be more practical if it's solved in the charge point firmware itself with a configuration setting. However, they can also be implemented using the charging profile mechanism of OCPP. As of this moment, the white paper is released, and you can access it and download it from our OCA website. I've put a link on the slide, so you can have a look for yourself. And if you are interested to become a member of the Open Charge Alliance, you can join us, and you can discuss with us all these kind of things, how we go further with the specification and these kind of things. So then I want to give the word back to Martijn.
Thank you, Milan. I will share the link to the white paper page in our chat box. If you have any questions, please ask them in the questions box. I've seen a lot of questions coming in, but first I want to give the floor to Ashley. Ashley, are you ready?
Yes.
There you are. I will make you, yes. Have your presentation ready?
Yes.
Let's
try that. There we go.
Okay.
Perfect. Thank you. So yes, I'm Ashley. I'm head of engineering here at EV.Energy, and just want to very quickly tell you what EV.Energy is before going into the details, just so you have some context. We are the smart charging platform. We sit between charger manufacturers, energy utilities, grid operators, and we use inputs from all of those people to smart charge electric vehicles in the most optimal way. We've been working in the UK since 2018. We now work globally, but we've been working in the UK since the start in 2018, and we have been working in this area of smart charging and grid services ever since then. So these regulations are highly aligned with what we've always done, and we're really happy to see those come in earlier this year. So I'm going to talk to you a little bit more around the real world. So we've talked about the theory of how you can do all of this implementation in OCPP, but things are not always that simple. So I'm going to talk through a few examples of where you might need to use alternative approaches from the ones shown in the white paper to achieve the same outcomes of meeting the smart regulations. I think the common issue between all of these is that domestic chargers typically have less compute power than perhaps public chargers. There may be implemented using smaller microcontrollers and things like that. So some of the functionality may not be available. But let's talk 3 areas in particular. So the secure connections part, the part coming in December, offline behavior, and randomized delay. So starting with secure connections. This is the part of the regulations, or part of the security regulations that are coming in December. For us, like was just recommended, we always use a least security profile 2 for any charger that connects to our system in production. We are very strict about that. We take security very seriously, so every charger must have a least security profile 2. But what issues do we see within this? What kind of issues do charger manufacturers perhaps need to be aware of whilst you're implementing this? We sometimes see issues with WebSockets implementations. So things like malformed WebSockets packets, issues with perhaps the ping pong, the messages that happen to keep the connection alive. Those are not common, but they do happen. We sometimes see issues with certificates. This is perhaps part of what I meant by those lower power kind of micro controllers. With encryption, you need to manage certificates, and the management of those certificates can be tricky and difficult if you're implementing that within embedded systems. So we have to be careful of that. And the third thing we see, it's kind of slightly outside of the scope of secure connections, but we often see slightly invalid OCPP messages in our system. We've chosen to be quite strict in what we accept from the spec, so we follow the spec quite strictly, and we see invalid OCPP messages fairly often. So things like where there are enums for certain messages, people implementing things outside of those enums, or kind of message formats that we don't expect. So those are all things that can be a little bit difficult, and you need to be aware of whilst trying to get these secure communications. We've seen this fairly often, so we do have a range of tools to help debug these issues and help people kind of resolve these. I think, yeah, often looking at network packet dumps and things like that. So secure communication is really important. We've got to get that. We've, as I said, we've had this. We've taken the approach of having this in place even before December, but we'll all need to do this before then. Offline behavior. So this is another thing called out in the specification that we've seen lots of approaches, or lots of different approaches taken. So when the charger drops offline, it should still function. It should still be able to charge the electric vehicle. So when we're applying smart charging profiles, we typically do that on a transaction profile. So that smart charging profile only applies for the length of that transaction. So from when they plug in to when they unplug. And then, as was mentioned earlier, you can use default transaction profiles to implement things like the default off-peak hours, or what you want to happen when the unit falls offline. But we see different approaches taken here. So I think according to the OCPP spec, those profiles, whatever they are, they should continue to be applied even if the unit falls offline. But some chargers take the approach of, if it detects a network drop, it will just fall back to immediate charging or some other behavior. You can also, I guess one thing that's relevant here as well, you can also try and use stack profiles. So if you're using default transaction profiles, you might want to stack various ones. So you have your default and then have something layered on top. We've seen some limitations with some charger manufacturers around them not just not being implemented. You can't use the stack levels for some domestic chargers. So another thing just to be aware of. The final area is randomized delay. This one's caused a lot of confusion. We've got a lot of questions on these ones. So it was explained what randomized delay is. The issue is trying to solve it is if we just all do a schedule and we say all EVs are going to start charging at midnight, there's going to be a huge step change in load on the grid at midnight, and that's going to cause the grid issue. So we want to add a ramp up and down to those changes in load, so there's no step changes in the power consumption. The white paper talks about the approach that you can use, but there's various other ones that we've used for chargers that don't support different parts of the specification. So there's on charging profiles, you have the valid from and valid to. And particularly the valid to, we sometimes add randomization to that valid to event, because we might say charge at 32 amps and then only make that valid to now plus 4 hours plus a random amount, so that if for some reason the unit does lose connectivity, that return back to not charge will be kind of randomized by that valid to event. We also find that you can add kind of scheduled periods within the charging profile of random length. So if you want to say pause charging for a random amount of time before turning it on, you can just add an extra kind of schedule period at the start of some random length between, well, it currently has to be between 0 and 10 minutes, but up to 30. So you can add a small period there of a random length to each charger to apply that. And you can, as was touched on earlier, you can set kind of transaction profiles and then set a random delay, but kind of fix that per charger. So it's as an aggregate, we are random and we are ramping up and down, but you don't have to dynamically change it per charger. There are a few things to watch out for here. There are some EVs, some vehicles that will not like it if you don't charge immediately when they plug in, or various kind of variations on that theme. So you might, firstly, we need to test very carefully with a range of vehicles, but you might want to think about the goal of this, about ramping up and down changes of load. We have to achieve that, but you might want to deploy your randomization in a kind of smart way, so the vehicles that may have problems if you pause charging when they start, they get the lower end of the randomization, so that they continue to function when they go back to charging. So lots of kind of pitfalls within this, but I think the main message here is that if you read through the regulations, there are various different ways that you can implement this. With OCPP, the white paper covers the recommendations, but there's various different techniques you can use, and you might need to diverge slightly from the recommendations to account for the specific needs of your charger or your EV. So those are just quick 3 areas. We have a blog post that talks more about what EV.Energy is doing around these smart regulations. So if you want to find out more, just put EV.Energy smart regulations into your search engine, and I'm sure you'll find the blog post. That was it from me. Very quick run through of some common pitfalls.
Well, thank you very much, Ashley. Let's see. I want Mathieu to give his vision on the white paper, and then we will be trying to answer some questions. Mathieu, are you ready?
Yes, I am. Do you see me?
Yes, I see you.
Okay.
And now I'll make you a presenter so you can share your presentation.
Okay, I am sharing my screen.
Yes.
Done.
Do
you see my screen?
Yes, and on presentation. Yeah. Here we go. Yeah. Yes. Okay. Good luck.
Okay. Good morning. Do you see still my webcam here?
Yes.
Okay. I don't know why it came out of my focus. Okay, so I am Mathieu Falcy speaking from Schneider Electric. I am a chief architect in the e-mobility BU, and basically we are providing hardware, charger, and software solution for charging infrastructure. And today, thank you, Martijn, for inviting me in this webinar to share our experience and why we went working with you on this white paper to resolve this UK regulation. So I'm just going to, let me see like this. Yeah. So here are a few, I would say, findings and sharing about what were the challenge that we faced when we started to discuss about this UK regulation and how we can deliver it to the market. And obviously, we came to a point where there are many challenges behind. The first being to make sure that we understand the regulation in the proper manner, because there might be some gaps, some interpretation, some understanding issue, I would say, between the lines. Second is to cope with a very short time frame that we had to comply with the regulation for smart charging, starting June this year, and cybersecurity end of this year. We aim to reduce uncertainties and to get upfront confidence about the proposed solution that we envision. And obviously, we would like to comply with the regulation, but keeping the user experience, I would say, at the highest level of satisfaction. And as we are an OEM operating at a global scale, we really looking forward a kind of flexibility and late differentiation in our supply chain to avoid for, building charger which are specific to a UK market only, I would say. So based on that status, we decided to meet you guys and the team to see how we can work this topic with OCA and get the support from the community to find out, I would say, consistent approach and I would say recommendation regarding the way OCPP can be used as an asset to really boost this compliance on the smart charging issue. So then I'm just trying to see the next slide. Yeah. So here is a very broad level picture just to give you an illustration of what will be a typical home setup, leveraging, of course, a smart charger, some app and tools for the electrician to configure the charger, and some other app for the owner to do the settings which are required by the UK regulation at the time of commissioning, but also at the time of operation when, for instance, it comes to override the several delay or schedule that have been set previously. So in this setup, you can see something very much in line with the OCA white paper recommendation, where, as it has been presented earlier, most of the smart charging capability and schedule and random delay are being managed on the backend system and then deployed to the charger using OCA CPP, I would say, features. And on the other way, you can see, you don't see it here, but on the security side, of course, we are also aiming to implement this event notification and secure firmware updates. So this is a typical home setup. The UK regulation apply as well in building when it comes to private charging as well. And you might envision having a similar architecture, I would say. So the proposed approach, and again, really taking the input that we shared with the team during the white paper work, I would say, is really going toward a full digital experience for the homeowner through an app, leveraging software capability at the backend side as much as we can, because it gives more flexibility and more freedom to, I would say, even enhance the feature and the user experience as we go. We are getting most of the smart charging capability from OCPP features. So here, clearly, we try to minimize the impact on the charger firmware. And we deployed an end-to-end security, as most of the security is built in the charger, And here, I don't think it is very specific to UK. Everything that has been requested in this regulation is fully relevant in some other geographies, I would say. So this is really something that it has to be in the charger, and of course then leveraging OCPP security extension for, I would say, the specific needs of the UK regulation. So I would say in very short, this is where we stand. Why we are struggling at the beginning to cope with this regulation, and how we decided to reach out to OCA for really building this asset. And I think it's now super great to see something that all the community can use and can take as a reference to provide something consistent across the market, I would say, and really building the confidence toward our compliance with this regulation. In very short, this is where we stand so far. So again, thank you to the team for building this white paper. Thank you for the work that you did in a very short period of time, I would say, between the time we meet up the first time and now that the white paper is published. I'll hand over to you, Martijn.
Thank you very much, Mathieu. I want to ask Milan and Ashley to join us with their cameras, so we can attend to the questions. There are a lot of questions, and I hope we can answer them all, but some we will answer through email. I will be logging them. Let's see first off. Here we go. Yes, first off, what's the first question coming in? Am I right that this regulation does not fit for public charging stations at all? Who can I give?
I think we can all answer this one. So, like I mentioned, it's for private chargers, but both for the domestic market as for the company. So, so not for public.
Not for public. Okay. And let's see. Ashley has mentioned this, but there were some questions about randomized delay. What is the purpose? I think you have explained it, but maybe you can repeat that. But and how does the randomized delay take into account the user's desired charge level by the time he or she unplugs?
Sure. So yeah, as I mentioned, the point of the randomized delay is to avoid those step changes. So you may have heard of like the secondary peak. So if everyone's charging overnight, there could be a secondary peak, a lot of charging around midnight. But what's worse is that step change. So if all the chargers are on a timer and they go from 0 to 7 kilowatts of charging immediately at midnight, there'll be a huge step change in load on the grid, and we want to avoid that because that's very hard to deal with. So that's the purpose. I think, like I said, we need to have a ramp on that load. We need to do that smoothly. And I mentioned one scenario where you might want to use that randomization tactic fully and to avoid any issues with EVs. Perhaps you also want to use your knowledge of the state of charge of the battery to choose which devices to randomly charge earlier versus later. But I think the other thing worth mentioning from the regulations is that the user can override all of these things. So if they want to charge immediately, you can allow the user to start charging immediately. And if you're doing it in response to a demand response event, you can, again, ignore the randomized delay. So there's some mechanisms built into the regulations to prevent that, and maybe you want to do something even smarter in your own platform.
Okay, thank you. Let's see. Milan mentioned a security profile too. We had some questions about it. Is it sufficient to comply with UK EV.SCP security regulation? yeah, the other question is almost the same, and it asks also, or is a WebSocket secure sufficient as a secure communication? Is something you can answer, Milan?
Yeah, so OCPP only describes those 3 levels. TLS, so with only server-side certificate is sufficient. But with OCPP, we also include at least basic authentication in that case. So the charger can send its username password combination to the server so that the server can verify that. Yeah, and you can also use the client-side certificates. That is more secure, but yeah, OCPP requires at least that to be implemented.
Okay, thank you. Let's see, I think this was in response to Milan's first presentation. Have you mentioned a ban on hard-coded security credentials and automatic network disconnection if unsigned software runs on smart devices?
There are some other things that I have not mentioned during the presentation that are in the regulations. I mentioned the most important ones, and the rest can be read in the white paper, because if I would go over all of them, we would have a very long discussion around that. But yeah, the passwords should not be hard-coded. OCPP makes that configurable, so you can set the password for your chargers, and you can use different passwords for all your charging stations. And we have requirements around that in OCPP as well. So.
Okay. And I think this question maybe be best suited for Mathieu. How is the implementation of profiles done from a product point of view? Is it on the charger's firmware or done from CSMS?
So I think this is in line with what we presented. So it's twofold. I think on the charger side, we need to make sure that the charger comply with OCPP specification, I would say, and this is also the challenge that Ashley has pointed that, okay, at least you need to ensure that the charger is behaving as per our expectation from the very standard OCPP, I would say, implementation. And then the specific UK, I would say, smart charging logic being mainly implemented on the backend system on the CSMS side, so that at the time of deploying the schedule, you can apply a peak hour, for instance, scheduling and a randomization of delay. So it is in two folds. I would say there is a standard behavior on the charger, and there is a specific behavior for UK in the CSMS system.
Okay, thank you. Let's see. OCPP on level 3 uses certificates. Is this allowed in the UK, as they state that passwords shall be used? Who can answer that?
Well, not sure about if it's mandated. Could be, but I could not think of a reason why client certificates would not be allowed to be used, because it's just more secure. So there's no reason not to implement that.
Yeah, to me, the regulation goes beyond the OCPP link, because there might be some other HMI or embedded web page or whatsoever web apps or mobile apps for which you can interact with the charger, and for which you need to have user passwords. So to me, there is OCPP link on one way, but there is also the user interfaces on the other way, where, of course, it has to be implemented the same password management.
Okay. Let's see. I hope I get this right. We'll transfer the information when the off-peak hours are to the CPO, and how? I think there's a word missing. Let's see. Does this make sense to any of you?
I think where those peak hour information comes from what I mentioned. So when are the peak hours? 8 o'clock in the morning. And like I mentioned in my presentation, you have those demand response communication with the grid operator or aggregator that manages these kind of things. But in normal situations, these should be static for most. So we can already expect at which point in times there will be most.
Yeah, I think that's, yeah, the default off-peak hours are defined in the specification, what those hours are. But yeah, so I think that answers the question.
Okay, and we've got more questions about randomized delay. Is randomized delay a solution to ensuring a peak initial load?
I'm not sure I quite follow the question, but I think I guess this is saying, like, if an individual charger ramps up that load itself, that could have the same impact. So I think, like, if your charger does implement a ramp up, or the EV implements a ramp up, then maybe that does solve the same problem. But I think it's quite hard to guarantee that all chargers will do that and all EVs will do that. So it's been mandated that you should, not send that start charge command or charge at 32 amps, whatever current you want, until a randomized delay has passed.
Okay. And how does randomized delay, as discussed, apply when recovering from a grid power failure?
This is one of the areas that's not so well described in the regulation. So from our point of view, from EV.Energy's point of view, we've tried to make sure that if there is a grid outage, we do ramp up that load slowly. So not all chargers will turn on immediately if the grid is recovering and coming back on, or even if a network has gone down, say a large Wi-Fi internet provider, like if that goes down and comes back up, we try to ensure that there won't be a step change in load. But in the regulations itself, it's a little bit vague on this. I think OPSS, who are the enforcers of these regulations, have answered a lot of questions, and I think you could look through the notes from their meetings to get more detail. But yeah, it's a little vague.
Okay, we have some Kevin House attributes to what you were saying. Let's see, maybe you can give a vision on this. At present, the times are fixed in the spec, and it does not allow for the industry to change them. Probably this will change in the later spec. And it's also worth noting that many of the details are effectively aligned with the specifications for smart metering load control. Randomized delay is an example, although it's slightly different in one detail. Is this correct? Or can you give a bit meaning or background to this?
But to me, this is true that this is probably an example of a regulation that went quite deep in the solution, I would say, that is prescribed. And on the contrary, we might also see some other area where we were sticking at the requirement and then giving more freedom to vendors for providing the most relevant solution. So to me, it is one of the challenges that we had. That is okay. On some regard, the specification was very detailed. On some other regard, it was still giving some area for interpretations.
Mm-hmm. Okay, let's see if we have. Are there regulations in place in the UK to allow to have a different energy supply contract with an energy supplier? If so, how is this handled in order of metering market messages?
So a different energy supply contract for the EV charging specifically. I think that's I'm actually not sure it exists, but it may exist, but it's certainly not common. So most people will have a single meter for their full domestic load, including EV charging.
Okay.
But overall, I think the proposed solution is agnostic from the utility electricity supplier. So whatever we have presented is really something that is linked to the charger and the apps and the backend system, and nothing specific to every electricity supplier. So to me, and this is one of the key requirements in the regulation, that is really to keep this flexibility towards the utility electricity suppliers.
Okay. Let's see. How does one resolve conflicting demands? An example, user overriding the effects of randomized charging profiles of third-party smart charging retail providers. One who asked questions has noticed EVs become non-responsive in the event of receiving conflicting recurrent signals.
Yeah, I think, as I said, some certain EVs will not like some certain ways of charging them. So the example I said is, if you plug in and don't charge immediately, some EVs will fail to then charge when you send them the command. So I suppose I suppose that's the challenge of backend software providers like ourselves, is to understand those conflicts, understand the needs of the chargers and the EVs themselves, and apply a combined profile with all of those inputs into the charger so that it does work as expected and meets all of those regulations. I think there's no easy answer to that, and that's why people like EV.Energy exist, to resolve those conflicts.
Okay, and I got some questions about the possibility of override. How will the user technically be able to override the settings if smart charging profiles are used? And a question behind that is if the delay can be overwritten, won't that defeat the purpose of avoiding the step change? Are there restrictions for this override?
I can take a first answer to that one as well, if you like. So again, chargers implement this differently. Some will have a boost type of button on the front of them that they can press, and then it will override. So chargers on our platform, we have a similar boost button in the app. So it will say kind of preparing to charge, and you can boost and override that. I think maybe slightly overrides the point, but not really, because I think most of this is going to be happening at midnight, 1 a.m., 2 a.m., this sort of thing. And if we're doing it right, a user's not going to mind about that delay. All they need to know is when they wake up in the morning, their car's going to be charged. And if we add an extra, for example, 6-minute delay to when it starts, it's not going to impact that. So for the vast majority of users, they're not going to use that override because they know their car is going to be ready. So because most people aren't going to use it, it's not going to defeat the point. The majority are going to have that delay, and it's going to smooth that curve at those hour intervals.
Okay, let's see. We are a little bit out of our time already, but I want to address a couple of questions, maybe one or two. Some questions are slightly too detailed or too complex to answer here. We will come back to that through email if possible. So you try to answer all the questions. Let's see the one I had. Will participation in the demand flexibility service remove the requirement to abide by randomized delays and default schedules?
Yeah, indeed. Yeah, I think this is good that they have taken in care the demand response specific behavior that is obviously against fixed and fixed profile. So there is this freedom for applying a different behavior in case of any kind of local energy management system or remote demand response, I would say, sign-out.
Okay. Let's see. I think that will be it for today. Thank you, Ashley. Thank you, Milan. And of course, thank you, Mathieu. We will be closing the session in a moment. First of all, I would like to thank all the participants, all the attendees for joining us for this subject, and I hope you've enjoyed it. As said, we wanted to answer all the questions. Perhaps that would be through email. Last of all, I want to let you know that I want to remind you that the Open Charge Alliance will be organizing an OCPP Plugfest on November 9 and 10th. So if you want to test your OCPP device, please check out our website, openchargealliance.org. The registration will start soon. Again, thank you all, and I will hope to see you soon. Thank you.
Thanks, everyone.
Thank you. Bye-bye.
Thank you. Bye.